Unit 5, and it's a lot of graphs. So, looking at your unit circle, as our angles increase, our sine values cycle from 0, a half, root 2, root 3 over 2, 1. Then they go down again, root 3 over 2, root 2 over 2, 1 over 2, 0, negative 1 over 2. So, if we graph that, it looks like this. So over a period of 0 to 2 pi, which is once around the circle, unit circle, our sine values go like this, peaking at 1 and negative 1 at 90 degrees, 180. You know all that stuff. We're just plugging these points in with respect to their angle. And that graph, since because of coterminal angles, that graph continues. And if you look at cos, it does the same thing, except it just starts on 1 and then goes to 0 and negative 1. So cos graph is just the sine graph. Uh, what do you call it? This sine graph moved half, like pi by 2 to the left, so that it starts on a 1 instead of starting on a 0. Okay, so with tan graphs, this is what they look like. Pi over 2, all the 90 degrees, 270 degrees. Whenever it's on this axis, it's gonna be what do you call it? Undefined. So you make asymptotes there. You start in the middle of them with at 0. So like at 0, 0 is at 0, at pi, minus pi, at 2 pi. All these multiples of pi are gonna be 0. And then you just uh, at pi by 4, like in the middle, it reaches 1. And then it just goes to infinity. And if you're going to the left, it goes to negative infinity. So just, yeah, I don't think there's going to be any questions, but just take a look at this. Maybe try graphing one yourself. And then, yeah. So this is what transformations looks like. It's again, same thing back to lesson 1. It's literally the same as the A, B, H, K values, except we change the H to a C and K to a D for some reason. Anyways, that doesn't matter. So going back to your normal sine graph, okay? So the max was 1, the minimum was negative 1. It started at 0, and this was 2 pi. Okay? So uh what A tells you, A is called your amplitude, and that's your distance from center axis, which is your D. Okay. So actually let me show you what D is first. D is the center. That's where the sine graph starts. So right now it's 0. So in a basic sine function, these are our ABCD values. So our D is at 0. Okay. Our A is the distance from our central axis to the maximum and the minimum point. So this distance right here, which as you can see, it's 1. Okay. And yeah. So the next thing is B, which is your period. Not your period. This is your horizontal stretch, and your period. Okay, period is the time, or not the time, the length it takes to repeat itself. So as you can see, this sine graph goes all the way around, and then it repeats itself, then it repeats itself, and its period is 0 to 2 pi. So one period is 2 pi. And when it's transformed, to find your period, it's 2 pi over b. And it can't be negative, so absolute value of b. The b can be negative, but your period can't. So 2 pi over b, because if you have a negative b and you flip the sine graph, it looks the exact same. So negative b doesn't matter. Okay, it flips in a sinusoidal function, which is what these are called, sine and cos graphs. And then if you're then now if you have, what do you call it? Actually, no, I'll get to that later. C value is how much it's shifted left and right from your like, remember h is literally your h value, but the advantage we have with sine graphs or cos graphs, sinusoidal functions, is they repeat. So they go like that. So whatever, since you're only graphing one period, which the curriculum says you only need to graph one period if you're told to graph it, what do? You take the center point, and that's the first point, and that's shifting, right? Because every single point is shifting. So you can technically just say C is your starting point. C is your starting x point. So if your C was 2, okay, it was x plus 2, it shifted 2 to the left. Instead of starting here, our graph would just start here, like that, okay, at negative 2. So C is your starting point. So just to summarize that again, D is, wait, let me highlight this. D is your central axis, okay. A is your distance from center to the to the max and min. C is your starting points, and D is your central axis again. Okay, and now how to actually graph these functions. So the steps are as follows. Take your D value, okay, and you make a line there. So at y equals -1, make a line. Okay, this is your central axis. And then using your a value, which is 3, you go up 3. So -1 plus 3 will be +2. You make a line there. And then -1 minus 3 would be -4. So in this direction, if you go 3, y equals -4. Okay. Now, what you do, you find your period. So period, remember, is 2 pi over your b value. So that's 2 pi over, what's our b value? Pi. Pi's cancel. So our period is 2. Now what we do, since we know now what we do is, and also our starting point is you flip the sign of the c value. So our starting point is +2. Okay. So now what you do, you take that point, and you know that your period is 4. So at 4, this is what you need to graph between these. Okay. So you need to divide this area up into 4 sections, because then it's going to make it easy to graph the max and min. So what you do, you take this period that you got, you divide it by 4. Okay, you divide it into 4 sections, you get a half, right? And so you graph a point at every half starting at 2. So first it's 2.5, okay, on your central axis. Then it's 3, which is the middle, okay. Then it's 3.5, okay. So these are your 5 main points. That's all you need to graph. Now the next hint is, you look at your function. Is it sine or is it cos? The only difference, oh, oops. The only difference that makes is where you start. Do you start in the middle or do you start on top? So since this is a sine, we start in the middle We go up, hit our max. This is where we hit our max. Okay. So we go here, hit our max. This is where we come back to 0. This is where we hit our minimum. And we go here. Okay. And now since we don't have an interval, like the question doesn't say, okay, you're only making the graph between x is 2 and 4, then we would not have these arrows. Since this is not the case, we need to put arrows to show that it continues. Okay, but we only need to graph this much, and then obviously mark the points. And yeah, that's how you graph. If instead, if this was cos, then all we need to do is we need to start on our max. We go down, up, down. Okay, complete a cycle. Now, what if it was negative sign? Nothing changes except we're going up. We just go down and up and down. Okay, we still start at the center. Everything else stays the same. It's just the our direction. And by negative sign, I mean if our a value is negative. Because remember, a can never be negative. All that changes is that negative is actually attached to your function. It's a negative sign, so it goes down at the start. Same with cos. If it's a negative cos, you start instead of starting up here at your max, you start at your minimum. So you go like this and this and this. Next up, we have finding the equation from the graph. So using our previous knowledge, okay, we will be finding this the equation from this graph. Okay, so let's just write our thing down. A sine cos doesn't matter. B x minus c plus d. Okay, and in here you can write sine, you can write cos, you can write you can write negative sign, you can write anything. I'll come to that point, this point again, but it all depends on your starting point. Okay, I'll come to that. So first, let's look at our d and a values. So our maximum point is at 5, minimum point is at -1. Okay, so their center, okay, is their average. Their center, looking at this, would be your 2. Okay, so your d is 2. And now we're seeing how much up and how much down these points are from 2. Well, this is 1, 2, 3 up. This is also 1, 2, 3 down, and it should be like that. That means our a value is 3. Next up, we look at our period. How long does it take for the graph to repeat? So let's just pick a point and see how long it takes for us to get back to the point. Well, it gets back right here. So it took us from 3 till 11. Okay, from 3 till 11. So our period is 11 minus 3, which is 8. And now to find our b value, remember how period is 2 pi over b? Well, if we just flip that, we get b equals 2 pi over period. So b equals 2 pi over 8. And that is going to be pi over 4. So our b value is pi over 4. And now comes the fun part. We can there's actually not just one equation that we can get from this graph. There's actually multiple, depending on where I start. Okay, you know how sine graphs works, right? If it was a sine graph, all that it needs to be, where's our d? Our d is here. all it needs to be, it needs to start at this line and go up. Okay, so it does that here, it also does that here. So right off the get-go, two equations become 3 sine pi by 4 x, flip the sign, minus 1 plus 2, or y equals 3 sine, everything stays the same, all that changes is the function and the c value. With So instead of positive 9 it becomes negative 9 plus 2. Now what if instead of positive sign I wanted a negative sign? Well, now the condition is that it needs to start in the middle still, but instead of going up it has to go down. Now where does it do that? Well, in my graph that I can see right now, it does that right here. It also does that somewhere there, but we don't have it, so it's fine. So it goes down here, starts in the middle, goes down. Which point is at 5? So another equation becomes minus 3 sine, because the negative sign just goes with the a. Okay, our a is still 3. So x minus 5 plus 2. Okay, that's another equation. Now, what if I wanted to do cos? What's the thing with cos? You have to start on your max. Okay, so these are our maxes. So two cos equations become y equals 3 cos pi over 4 x, which what point is this? Minus 3 plus 2 y equals 3 cos pi over 4 x minus 11 plus 2. Now what if same thing with sine, I wanted to do a negative cos? Well, all I need is now minimum points, because it starts on minimum and goes up. So two more equations we can get. You get negative 3 cos, so negative cos pi over 4 x, flip the sign, plus 1 plus 2 y equals negative 3 cos pi over 4 x, oh, flip the sign, minus 7 plus 2. Okay, so if this graph was extended even more, like if I could see more of it, I could probably make infinite amount of equations, because the graph goes on forever, right? So yeah, all that changed was your functions and your starting points. Okay, everything else, the a, b, and d values, they remain the same for all of those. Okay, so now moving on to finding the equation without the graph. This is very easy. So a max is at 0, 4, min is at pi over 4 and negative 2. So again, we need a, b, c, d values. And with these type of questions though, you know how we made any equation? It's pretty hard to find the medians sometimes. So just make a cos graph, because you already have the maximums and the minimums, right? It's not telling you to make a sine equation, it's telling you to make any equation. So in these cases, always prefer cos. Okay, so our a value, as you know, actually let's start with d. Our d value, as you know, is the average between your highest and the lowest point. Okay, it's your average of y values. So it's gonna be y value of max plus y value of min over 2. Okay, so in this case that's gonna be 4 plus minus 2 over 2, which is 4 minus 2 over 2, which is 1. Okay, your a value, your a value is the distance between the middle and the top. Okay, so now it's the difference between is the difference between the maximum and the minimum, and then you divide that by half. So it's y max minus y min over 2, and then take the absolute value. Just turn it into positive. You should get a positive number. So you get 4 minus 2 over 2, 4 plus 2 over 2, which is 3. So why did we do minus? Because it's just the distance between these, right? So you subtract it, then you find the distance between these. But amplitude is the distance from the center. So it's just this line split into two. So it's just the difference over 2. And it has to be positive. Next up is our b value. So our b value is a period. So for our graph, let's just say any graph. For this graph, we took 2 points that are the same. So a max and then another max, right? In this case, we have a max and then a min. So if we were to graph it out, it would get to that max at some point, right? And the distance between a max and a min, we need to double that distance to get to that. So what is the distance between the max and min? Now we're talking about the x values, okay? So the distance is from 0 to pi by 4. So the distance is pi by 4. And now if you add another pi by 4, what point do you get? You get pi by 4 plus pi by 4, which is 2 pi over 4, which is pi over 2. Okay, so that's our period. Our period is pi over 2. So our b value is 2 pi over 2. Dividing by a fraction is multiplying by its reciprocal. These two cancel, and our b value is 4. Our c value, as you remember, is anything we choose. And since we're choosing a positive cos, it's going to be our max. Okay, so our c value, the x value of our max, so our c value is 0. So now if we are to combine all of these, it becomes y equals 3 cos, positive cos. And what's our b value? B value is 4 x plus 0. You can also skip this because you adding 0, same thing. And then our d is positive 1. Okay, and then another equation. How about you give me another equation for it? Take a second, give me another equation for this. Well, if we have a negative cos, right, all that changes, and instead of starting on the max, we now start on the min, right? Because negative cos starts on the down minimum and goes up. So our c value changes from 0 to pi over 4, and our new equation with a negative cos becomes x, and you flip the sign, minus pi over 4. So that's what you do for finding equations. Okay. Next up is solving. So with solving, this is a bit different from the last one because we didn't have anything in here. We either had a 2 theta straight up and then we used our identity, or we had something else. But now we have a whole period and a c value to it, right? So whenever you have these type of questions, all you're doing is you're isolating the trig function. Okay, so to isolate the trig function in this, 2 cos pi by 3 x plus 1, we can just say this whole thing is theta. Okay, this whole thing is theta minus 1. So what do you do to isolate it? You get 2 equals 2 cos theta, divide by 2, divide by 2. Cos theta equals 1. And so theta equals, what do you call it? Oh, in the interval 0 and 2 pi, what makes cos theta equals 1? Well, it's 0 and 2 pi, not degrees, radians. And what was our original theta? It was this. So we get pi by 3 x plus 1 equals 0, and pi by 3 x plus 1 equals 2 pi. So now we can just solve for x. So this, you multiply both sides by, well, divide both sides by, multiply both sides by 3 over pi. This just gets cancelled because there's a 0 here. So it becomes x plus 1 equals 0. X equals negative 1. That's our first answer. Okay, here you multiply both sides by 3. By 3, you get pi x plus 1 equals 6 pi. Divide both sides by pi. Okay, basic stuff. X plus 1 equals 6. X equals, subtract the 1. X equals 5. So those are our two answers, negative 1 and 5. But if you look at your interval, okay, x cannot be negative, so this is not a solution. Your only solution is x equals 5. Now if you're to solve it graphically, you know how to do that. You just graph both equations, the left side and the right side, and then over the interval 0 and 2 pi is 3.5 3.14 times 2, 6.28. So it's about like here somewhere, 6.3 almost. Okay, so the only time they touch is here. So that's when x equals 5. That's how you solve it graphically. Now with some of these solving problems with periods, keep in mind between x and 2 pi, you might think there's two answers always, but as you saw, that's not the case. Sometimes they're less, sometimes they're even more, like in this case. So again, the first thing you do, you isolate for your function sine theta, divide both sides by 2, you get 1 by 2. And so when is sine theta positive 1 over 2 in one period? Well, it's theta equals cast rule, CAST is positive here and here, and sine theta is half 1 by 2 at pi over 3. Where's my pen? Not pi over 3, pi over 6, my bad. So theta is pi over 6, and pi in the second quadrant it's pi minus pi over 6. So it's 5 pi over 6. Okay, so now we get 2 pi over 3 x equals pi over 6, and 2 pi over 3 x equals 5 pi over 6. If we multiply both sides by 3, we get pi over 2, and divide by 2, we get pi over 4. Here, well, just doing the same thing, we get 2, and we get 5 pi over 4. X equals, okay, by canceling 2, multiplying it, I mean, dividing it. So these are the two solutions we get. Oh, wait. The pi's cancel out too. So we get 1 over 4 and 5 over 4. But in these cases, especially when the pi's cancel out, okay, always, always look for your period. Your period is uh 2 pi over 3, I mean 2 pi divided by 2 pi over 3, right? So that is equal to 2 pi times the reciprocal. So your period is 3. And remember how we used to find coterminal angles? Like if our angle was 60 degrees, okay, it's like that. If we were to add another rotation to it, we would add 360 or like add 2 pi. 2 pi was our period then. Now our period is 3. So technically we can add 3 to these, add 3 to these and get even more answers. So 3 plus 1/4, it becomes 3 and 1/4. This is 1. And then 5 by 4 plus 3, that becomes uh, 4 and 1/4, right? If we add a 3 to this again, we get 6 and 1/4, which is 6.25. But what is pi? I mean, 2 pi? 2 pi is 6.28. So even this answer is valid, okay? If we add 3 to this, 4 and 1/4, we get 7/4. But 7/4 is greater than 6.28, so that's not a valid answer. So there's actually 5 valid answers in this case, okay? So whenever there's a question with a period, there's a algebraically solved trig question with a period, with a b value like that, not the identities like this. Especially when you see a cheeky pi there, you find your period, and whatever answers you get, you add your period until you cross that interval line. Okay? And now the last thing is word problems. So word problems in this unit are actually easier than you think. You just need to visualize it kind of. And they're also there's a lot of them on the exam. I think there's one every exam or something, or maybe two. So do a lot of these, but it's pretty easy. So a Ferris wheel, what I like to do is I'll always like to draw it out. So the Ferris wheel with the radius of 25 placed 1 meter above the ground. So placed 1 meter above the ground vanishes sinusoidally with time. Okay, so I guess that means goes around. The Ferris wheel makes one rotation every 24 seconds. One rotation every 24 seconds, with a person sitting 1 meter from the ground and rising when it starts to rotate. So obviously the person's here, and then they're going this way. Okay, so what's our first question? Write a sinusoidal function that describes the function from a person's starting point. So they're talking about the person's height here. Okay, so how you write these are, since we're talking about height, you take the height function of the time. It's usually this just means that our variable is time. Okay, so because our independent and dependent variable, you know what I mean, just logic it out. And okay, I won't write this. Hopefully that didn't confuse you, but you probably know what I mean. So our central axis, okay, our central axis is what do you call it? So our max is 26, okay? Our minimum is 1, like in terms of height. You start at your 1, you start at 1, you go up to 26, and then you go back to 1. Okay, so your graph you can already kind of see is gonna look like this. Okay, so you're starting on your minimum. So what to find your equation, what things do we need to find? A, B, C, and D. Okay, so first of all, you look for your D. Your D is your max plus min, your average over 2. So your D is going to be 26 plus 1 over 2, which is 27 over 2, or I'll just write it in terms of decimals. It's going to be 14.5. No, 13.5. Your A is the opposite. It's the difference divided by 2. So 26 minus 1 over 2. So that's 25 over 2, which is 12.5. Your B period is well your your period is 24 seconds, as it says in the question. It repeats every 24 seconds. So your period is 2 pi over 24, which is pi over 12. Okay, and your C value is whatever you want. I'm just gonna take the beginning because it's on our minimum point. So we can say what function starts on a minimum point. We can say our C is 0 and our function is a negative cos, because it just says sinusoidal function, so we can write any function we want. So our answer becomes y equals, it's a negative cos function, so negative 12.5 cos, I'll just erase this, and b value is pi over 12 x plus 0, and then plus 13.5. Okay, and now how high above the ground would a person be 16 seconds after the Ferris wheel? Also, this x, since we're talking about seconds, it's time, and your y is, like I said, age of t, or just height. Okay, so keep that in mind. Use your variables based on your question. And now, how high above the ground would a person be 16 seconds after? Well, all you do, you take this t, you plug in 16 seconds for it. So you got 12.5 cos 16 pi, because 16 plus 0 is 16, times pi is, well, 16 pi. So this becomes 4 over 3 pi plus 12.5. And you can, this probably be a, oh, not 12, 13.5. Calculator question, so just plug it in and you'll find your height. And that's it for trig.